Okay, guys, so this video is going to cover notes 8.2. This will be going over Pythagorean theorem and its converse. So the very first thing we want to look at is the Pythagorean theorem. So the Pythagorean theorem, the formal definition for it says that if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the lengths of the hypotenuse, right? I think that most people are just more familiar with this formula. So when it comes to Pythagorean theorem, the formula that you need to understand that we're working with is a squared plus b squared is equal to c squared. And in this formula, what I want you guys to understand is that your A and your B represent the legs of your right triangle. Okay, so make sure that you're familiar with what is a leg and what is your hypotenuse. Your hypotenuse is always going to be across the 90-degree angle. So that hypotenuse is always going to be your C value in Pythagorean theorem. So that is your hypotenuse. And the other thing I want you guys to understand is that this is always your longest side. So the C value is always going to be your longest side. Okay. And this is something we're going to want to make note of here. I promise you I wouldn't be writing this down for nothing. So in Pythagorean theorem, again, I know I'm repeating things a lot, but it's really important for you to understand that Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the hypotenuse, which would represent the longest side of your right triangle. So the next thing we want to go ahead and look at is something known as a Pythagorean triple. A Pythagorean triple is known to be a set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. All this basically means is for us to have a Pythagorean triple, we're going to be looking at a squared plus b squared equals c squared, and the result is going to be that they're all whole numbers, right? And so one thing you're going to want to make note of here also is that any multiples of Pythagorean triples will be Pythagorean triples themselves. And I'll kind of explain more about what this is saying after looking at some examples here down below. These I'm going to kind of just run through really quickly here. So these are some Pythagorean triple examples. So it says find the missing side to each right triangle. So if we're going to do that, when you're using Pythagorean theorem, you need to know at least two sides of any given right triangle. In each of these scenarios, we know at least two sides. So if I'm doing Pythagorean theorem here, then we can understand this is my A, this is my B. The hypotenuse, remember, is always your C. The hypotenuse is across the 90-degree angle. The hypotenuse, I don't know what it is, so I'm going to call it X. So if I do Pythagorean theorem here, we're looking at a squared plus b squared equals c squared. This is going to be 3 squared plus 4 squared is equal to our c squared, which c we labeled as x. So that'll be x squared. And now we just go ahead and square this. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, so 16. And that's equal to x squared. If I add these numbers together, 9 plus 16 gives us 25. That's equal to x squared. If I square root this to solve for x, then what you end up with is 5 is equal to x. So we can look here that our value for c, the hypotenuse, is 5. And this would represent an example of a Pythagorean triple. Look at all of our side lengths. We have a side length of 3, a side length of 4, and a side length of 5. When all three side lengths are whole numbers, then that means that it represents a Pythagorean triple. Let's check the next one. We got 5, 12, and we're looking for this missing side, which we'll call x. So if I'm doing Pythagorean theorem, I always like to start labeling my hypotenuse first. So my hypotenuse is my c. It doesn't matter if you make 5 the A or the B. What does matter, though, is that C is your hypotenuse. So if we plug those values in, we're doing 5 squared plus 12 squared is equal to x squared, right? Following that formula that we have here at the top. 5 squared is 25. 12 squared is 144. And that's equal to x squared. And if you're not sure where to get these numbers from, you can obviously just type these into the calculator, and that would tell you what these numbers are going to give you. So what we do now is we add 25 and 144. That gives us 169 is equal to x squared. And in this case, we would square root. And when you square root, one thing that needs to be kind of noted here is that sometimes it's going to give you a nice whole number. Sometimes it's not. So realistically, what you would be doing here is just check. Before you start doing the little factor tree and simplifying the square root, check. My calculator is a little bit different, so I have to type in the number first. But if I want to take the square root of 169, when we do that, we see that it gives me a whole number of 13. So if I square root this, I just get 13 is equal to x. So this side here is 13. And again, this represents a Pythagorean triple because all of the side lengths are whole numbers. And so what we're going to see here is that this triangle here at the very end is going to be an example of a multiple of a Pythagorean triple. So let me actually get a highlighter here. Look at the relationship between these side lengths. Okay. This is basically being multiplied by some number, and if every side length is multiplied by some number, then the result is also going to be a Pythagorean triple, right? Assuming that the first triangle you're working with is a Pythagorean triple. So how do I go from 3 to 15? Well, what they're doing is they're multiplying by 5. So what we see here is the 3 is getting multiplied by 5 to get 15. The 4 is being multiplied by 5 to get 20. That would mean that my hypotenuse would have to be also multiplied by 5. And that would tell me that, hey, my missing side length here should be 25. And I'm going to prove it to you really quickly just by doing Pythagorean theorem. So if I do Pythagorean theorem here, this is your A, this is your B, your hypotenuse is your C. So this would be 15 squared plus 20 squared is equal to 25 squared. Well, actually, let's pretend like we didn't know it was 25 squared. We'll work and call it x squared. So if I square this, 15 squared is 225. 20 squared is 400. And that's equal to x squared. Adding these two guys together, we get 625 is equal to x squared. And you can double check here with the calculator. If I want to take the square root of 625, because that's essentially what we're going to have to do here to solve, we're going to square root. Then let's type it in and see what it gives us. If I type in 625 and we take the square root of that, the result is 25. So we were right. So 25 would be the value of that missing side length, the hypotenuse. Okay, so this was what I was trying to emphasize earlier that is highlighted in blue, which says it's important. If I have a multiple of a Pythagorean triple, then that new right triangle is also going to be a Pythagorean triple as well. Okay, so let's just look at a few more examples. We're going to run into some instances. Not every single problem that we look at is going to be a Pythagorean triple. In other words, not every single problem that we use Pythagorean theorem on is going to be a whole number. Sometimes you're going to get decimals. Okay, sometimes you might get square roots. Okay, so let's look at these two examples and see how these are going to be a little bit different. So if I look at this example, number one, it says solve for the missing side. Leave your answers in simplest form. So my missing side length here, we're going to call this x. Okay, I'm missing this side. Now, this side also happens to represent your hypotenuse. So that is your C. We'll call this A and we'll call this B. So if I'm doing Pythagorean theorem, remember that we're working with a squared plus b squared is equal to c squared, right? We can do Pythagorean theorem only for right triangles, and I should have mentioned that earlier, but Pythagorean theorem is only for right triangles. And if we're plugging our values in here, A is 6, so I'm going to do 6 squared plus b squared would be 12 squared is equal to c, which we have labeled as x, so x squared. And now we just start to work it out. 6 squared is 36. 12 squared is 144. And that's equal to x squared. So what we're looking at here now is, well, I can add these two numbers together. 36 plus 144 would give me 180. So we got 180 is equal to x squared. Well, if I want to solve for x, I'm going to take the square root of both sides. And again, probably something I should have mentioned earlier, but we've been working with square roots for quite a bit. But just in case, just kind of a reminder, when you square root a squared, it basically cancels each other out, leaving you with just the x by itself. So we're left with x is equal to the square root of 180. So at this point, we would want to go ahead and check with the calculator, what is the square root of 180? So if I were to look at the square root of 180, let me type in 180. If I take the square root of that, you see that we get this really long decimal, right? We want our answers to be exact here for this class, and I don't expect anybody to write out that decimal. That decimal actually goes on infinitely. There's actually more numbers. The calculator just doesn't have enough space for it. So rather than writing down this really long decimal, what we're going to do is simplify this square root. So like we did in the very first day of notes in this packet, we're going to simplify the 180. So thinking of two numbers that multiply to give me 180, if it's a big number, if it's an even number, I always like to just take and break it down by 2, right? 2 times, well, I know 2 times 90 would give me 180. So 2 is prime. 90 can get broken down into, well, 9 times 10. 9 gets broken down into 3 times 3. There's prime numbers, so those are the end of my branches there. 10 can be broken down into 2 times 5. And so now what you're going to end up doing is this square root of 180 is going to be replaced with the numbers that you got at the end of your branches. So 2 times 3 times 3 times 2 times 5. And what we're looking for here is, do I have a pair of the same numbers? Well, yeah, I have a pair of 3s. So that means that that cancels out and 1, 3 comes outside. And I also have a pair of 2s, right? They're separated, but that's okay. There's one pair of 2s there. That means that a 2 comes out. Now, if more than one number comes out of that square root, remember that we multiply those numbers together. And all we have left underneath the square root is just a 5. So the result here is going to be after we multiply 2 times 3, we get 6. So 6 square root of 5 is equal to x. So that is the simplified form of the square root of 180. So that is what we're looking for our final answer, right? If you can simplify that square root, simplify it. But definitely go ahead and double check first to see if you have to simplify. Because if you get something like, I don't know, let's just do 81. If you take the square root of 81, it's just 9. Don't go through that process of, breaking down with the factor tree here if you get a whole number when you take the square root. Okay, let's look at the next one. The next one is just slightly different. So in this next one, we are still looking at solving for the missing side here. In this case, the missing side they labeled for us as x. If I'm looking at utilizing Pythagorean theorem here, we understand that we want to make sure that we label the hypotenuse with c. So my hypotenuse here is across the 90. Across the 90 would be 11. So that's my hypotenuse. And I'm going to call this side length of x a, this side length here b. So if we're following this formula per Pythagorean theorem, if I plug my values in, we're looking at starting with a. This is going to be x squared plus b. B is 9 squared is equal to c squared, which would be 11 squared. And then we just start to work it out. X squared just stays as x squared, but 9 squared gives us 81. 11 squared gives us 121. From here, now we're treating this as an equation that we want to solve for x, right? So in other words, I want to get the x by itself. Right now, the x is on the left-hand side, so I need to cancel out the 81, and I need to cancel out the squared that's attached to the x. We're going to start with canceling out the 81 first. So to cancel out a plus 81, we're going to subtract 81. Doing so leaves us with x squared is equal to, well, 121 minus 81 is 40. And then now we can go ahead and cancel out this exponent of 2. To cancel out an exponent of 2, we square root. What that square root does, like we said, cancels out the exponent of 2, leaving you with x is equal to the square root of 40. And then again, like we mentioned earlier, always double check first. If you're not sure, okay, square root of 40, does that give me a nice whole number? Nope, we get a super long decimal, so that tells me that I need to simplify this radical, and we're going to try to see if it simplifies. So 40 can be broken down into, well, 2 times 20, 2 is prime. 20 can be broken down into 2 times 10. 10 can be broken down into 2 times 5. And that represents the end of my branches when simplifying here. So that square root of 40 is going to be replaced with, instead of 40, we're looking at 2 times 2 times 2 times 5. All right, and we'll see here that we have a pair of 2's. So one pair of 2 comes out, and what we're left with here is x is equal to, well, 1, 2 came out, so 2. And I don't have any other pairs here, so what we have left under the square root is 2 times 5, which is just 10. So our value for x here on this problem is going to be 2 times the square root of 10. So in this class, now that we're looking at this at a slightly higher level than what you probably saw in middle school, some of the answers that you get for using Pythagorean theorem, you're going to get some square roots as a part of your final answer, and that's okay. That is totally fine. Just make sure that you're simplifying whenever possible. Okay? So let's go ahead and look at the next section of the notes. The next section of the notes is just basically just giving you a reminder what the Pythagorean theorem says. Okay? And for the Pythagorean theorem, it needs to be noted here that Pythagorean theorem only works for right triangles. So this basically says that if a triangle is right, then a squared plus b squared equals c squared, right? Now, what I want you to consider is what would the converse of this statement say? Remember that the converse goes back to our book project from the beginning of the year. In a conditional statement, a statement basically that has the words if and then, this represents your hypothesis P. This represents your conclusion Q, right? What the converse does is instead of writing P then Q, it swaps the order. So it's going to be if Q then P. So the converse of this statement would say if, but now I'm writing the Q part first. So if a squared plus b squared is equal to c squared, then now we're going to write P. Then the triangle is right. So this is actually super important because now we're going to look at some slightly different kinds of questions. This basically says that if I use the formula for Pythagorean theorem, if I use a squared plus b squared and it's equal to c squared, then that tells me that the triangle we're looking at is a right triangle. And so what you're going to notice is we're going to basically run into three different kinds of scenarios. The three different scenarios that we can run into here is going to be the following. Okay. When we use the converse of the Pythagorean theorem, which is the converse of the Pythagorean theorem is literally what we just wrote here in blue. When we use the converse of that Pythagorean theorem, not only does it tell me if it can be a right triangle, but it's also going to be able to tell me if it's acute, obtuse, or right. The only thing that you need to make sure that you remember is when doing this, remember that when using the formula, your C in Pythagorean theorem is always the longest side. Okay, that is super important. So make sure that C is the longest side when you're doing these problems. Okay, so let's run into the three possible scenarios that you can have. Okay, in the first scenario, if you use Pythagorean theorem, a squared plus b squared, and it's equal to c squared, so in other words, if c squared is equal to a squared plus b squared, then it's a right triangle. Okay. For these to make sense, you're going to look at all of these scenarios from the perspective of C. So look at the scenario that we have next for acute triangle. If a squared plus b squared is greater than c squared, let's look at this from the perspective of C. So that's what we have in parentheses down here. If I look at this from the perspective of C, okay, I'm not an artist, but this is literally what I'm trying to get you guys to do. Okay, that's my attempt at some eyes here. If you're looking at this from the perspective of C, then it's noted that C is less than the amount that we get for a squared plus b squared. So if c squared is less than the a squared plus b squared, then it's acute. And then lastly, again, we're going to look at this from the perspective of c squared, okay? Because right now it reads a squared plus b squared is less than c squared, but look at it from the perspective of c. So again, pretend like you're looking at it from here. In this case, the symbol that we have here is opening up towards the C. So this would imply if I'm looking at it from C, from the perspective of C, C squared would be greater than or more than A squared plus B squared. Okay. And this will make a little bit more sense as we look at some examples here down below. Okay. So in the examples that we have down here below, there should be kind of some instructions here. And typically what these problems will be phrased as is it'll basically say something along these lines. Classify the triangles as acute, right, or obtuse. So that is typically how the questions will be worded for these types of problems. Classify the triangle as acute, right, or obtuse. To do that, you're going to use Pythagorean theorem. You're going to check to see, is it equal? Is it c squared, is it less than? Or c squared, is it more than? To determine whether it's right, acute, or obtuse. So let's just kind of jump into it and see kind of what I would like for you guys to do when setting this up. So when setting this up, we're basically using the formula a squared plus b squared. And I'm going to put a box here because right now I currently don't know. Is it equal? Is it greater than? Or is it less than c squared? What you do need to make sure of is what we said earlier. Okay, what we said earlier is c is the longest side. So if c is the longest side, look at number 3. What side is the longest? The side that's the longest here is 12. So that has to be my c. Now, a and b, not as important. A and b, you can call it 8 can be A or you can call it B. Doesn't matter. But what does matter is that C is the longest side. So I'm going to call A 8. And then my B side is going to be 6. So now let's go ahead and plug this in. If I plug this in, I'm looking at A squared is going to be 8 squared. Plus B squared is 6 squared. And we're going to check. We're going to compare that to C squared, which C is 12. So 12 squared. Well, if we work this out, 8 squared is 64. 6 squared is 36. And we still don't know yet. We're going to compare that to 12 squared, which is 144, right? And you're more than welcome to use a calculator here if you're not sure what 8 squared, 6 squared, or 12 squared is. But now if we go ahead and add 64 plus 36, what that ends up giving me is 100. And now we can go ahead and fill this in with the correct symbol. How does 100 compare to 144? Well, the 144 in this case is the bigger one. And so look back at what we had in the beginning. Remember how we left this box here? Now I can fill this in. Now, after working this all out, we saw that the left-hand side, a squared plus b squared, is actually less than c squared. So I'm going to write the appropriate symbol here. There's the appropriate symbol. And when you answer this question, is it right, acute, or obtuse? Look at it from the perspective of c, okay? My c squared is on the right-hand side. This c squared happens to be greater than the left-hand side. So if c squared is greater than or more than, then this tells me the triangle is going to be obtuse. And so that more or less is the idea that we're working with here. Okay, so this is an obtuse triangle. And that's how you're going to classify these triangles. We're going to look at number four. Number four is very similar, just kind of with a little bit of a twist. Okay, so let's practice with the next one. So if I want to classify this next triangle, number four, we're looking at, putting this in the format of a squared plus b squared and comparing that to c squared. The only problem here is it's not as obvious which side is the longest, right? So I know that obviously between 7 and 8, 8 is the longer side, but I don't know the value of a square root of 113. This would be a good instance where you would want to check with the calculator. So I would check with the calculator. And what I would do here is I would check what is the square root of 113. So if I take the square root of 113, I see that that number is approximately, let's say 10.6, right? So if this side length here is 10.6, that would tell me that that is the largest side. So it's safe for us to go ahead and label this as C. That is going to be our longest side here. So if that's C, we can call 7, 8. I'm sorry, 7, we can call that as A. 8, we can call that as B, right? And so now we'll go ahead and plug these values into our Pythagorean theorem. So if I plug this in, we have 7 squared plus 8 squared. And we're going to compare that to, well, now this is a little bit weird. I'm actually going to put this in parentheses. Square root of 113 squared. Okay. So let's work with the left-hand side first, and let's see what happens on the right-hand side. So 7 squared is 49. 8 squared is 64. We're going to compare that to the square root of 113 squared. Well, remember earlier when we were solving? Earlier when we were solving, I kept telling you guys that a square root cancels out a squared. So what's actually happening here is that the square root cancels out the squared. So that leaves us with just plain old 113. And if you don't believe me, you can check with the calculator here. If I look at, let's do the square root of 113. So if I take the square root of 113, and then I'm going to click this button, that button will square it. We get 113. So right here, my calculator, like I said, it's not like the yellow ones that you have, but this is me trying to prove to you that if you take the square root of 113 and square it, you're going to get just plain old 113. Again, if you don't believe me, just plug what we have here in the calculator. It's going to spit out 113. And so now we're just going to add the left-hand side. If I add the left-hand side, I'm doing 49 plus 64. So 49 plus 64 is going to give us 113. So we have 113. How does that compare to the right-hand side, which is 113? Well, you should hopefully realize here that, well, it's equal. So if it's equal, then look at the scenario that we just ran into. The scenario that we have here is that a squared plus b squared is equal to c squared. What happens when that c squared is equal? We say that it's a right triangle. So this is going to be a right triangle for number 4. Okay, let's practice with the last one. Number 5, we're looking again, kind of a similar situation as the problem that we just did. We have a side length of 9, a side length of 11, and then we got the square root of 115, right? So here, again, not super clear which side is the longest, right? It's probably debated between 11 or the square root of 115. So check with your calculator. How much is the square root of 115? Let me make this a little bit bigger so it's easier to see. So if I want to find the square root of 115, we're going to square root it. And we get approximately 10.7. Right? Between 10.7 and 11, 11 here is going to be the largest side. So let's go ahead and call the 11 RC then. We'll make this one A and we'll make this one B. So if we're doing Pythagorean theorem here, we're checking a squared plus b squared. How is that going to compare to c squared? Well, going through this process here, my A is 9, so I'm going to plug it in as 9 squared, plus B is square root of 115. So I like to put it in parentheses, and then I square it. And we're comparing that to C, which is 11, and we're going to square the 11. So as we work this out now, 9 squared is 81, plus, well, we just mentioned earlier that the square root of 115. If I square a square root, it cancels out, leaving you with just 115. And we're going to check how does that compare to 11 squared, which is 121. Okay. Well, if we add these guys together here, 81 plus 115 is 196. And we're looking at 196 and 121. Okay. Here we're going to see that the 196 is bigger. So here's the symbol that I'm filling in here for my scenario. When you're looking at this, though, again, look at it from the perspective of c. What can I say about c squared? In this case, c squared is less than the a squared plus b squared. If c squared is less than, we have this situation right here, basically. This tells me that the triangle is acute. So this will be an acute triangle. Right. So as you guys are practicing with the homework assignment, definitely kind of use these three scenarios as your reference when deciding if it's acute, obtuse, or right. The last question we're going to look at here in the notes is just going to be a word problem. So in this word problem, it says an isosceles triangle has leg lengths of 26 centimeters and a base length of 20 centimeters. Find the length of the altitude. I'm just going to do a brief recap of isosceles triangles. Isosceles triangles are triangles that have two congruent sides. We call these the legs. And the remaining side is going to be called your base. Okay. So as we read this question, we have an isosceles triangle. So I'm going to draw my isosceles triangle. We know that it's going to have two congruent legs, and it actually tells you that these leg lengths are 26 centimeters. So my congruent legs here, we're going to label as 26 and 26. It also tells you that it has a base length of 20 centimeters. So the base, remember, is at the bottom. So this base length is 20. All right. And they want you to find the length of the altitude. And I purposely kind of left this part out because I wanted to read it at this step right here. Okay. This part's extremely important. When you drop an altitude in an isosceles or an equilateral triangle, what happens is that it bisects the base and the vertex angle. So watch what happens as we draw in this altitude. Okay. My altitude here goes from the vertex to the opposite side, creating a 90-degree angle. What we're saying is that what this altitude does is it's going to bisect this top angle, which really isn't important for us for this problem. But what is important is that it also bisects the base. So this base of 20 is now being bisected. So if this 20 were to get bisected, it means that it got cut in half. So this would be 10 and 10. Now, the question here is asking you to find the length of the altitude. My altitude is this black line here, so I'm going to call it x. I want to find the length of that altitude, and kind of piecing this all together, what you should hopefully see now is the right triangle that I'm highlighting here in yellow. Okay, let's separate that out so it's just a little easier to look at. So if I separate this out, in this right triangle, we have this side length is 26, this bottom side here is 10, and we need to find x. So now this pretty much looks like one of the first examples that we saw in the notes. If this is a right triangle, then I can use Pythagorean theorem to find my missing side, right? The only thing I need to make sure I label carefully is my c. C is the hypotenuse. My hypotenuse is across the 90, so that tells me the 26 is my hypotenuse. That has to be c. We'll make x a, and we'll make the 10b. So if I plug this in now, I'm looking at x squared plus 10 squared is equal to 26 squared. So on the left, we have x squared plus 10 squared. 10 squared is 100. That's equal to 26 squared, which I'm not sure off the top of my head. I think it's 676, but I could be wrong. 26 squared is 676. Okay, just making sure. So we got 676 here. Now, if I want to solve for x, which we labeled as the altitude, then I need to get the 100 canceled out. So we're going to subtract 100. This gives me x squared is equal to 576. If I want to solve for x, remember that a square root will cancel out a squared. So now we're just left with x is equal to the square root of 576, right? So let's check with the calculator. Hopefully that gives us a nice number. If we look here, the square root of 576, oh, it does. So we get 24. So this tells me that x is equal to 24. But the question asked you to find the length of the altitude. Okay, so we understand that the altitude here is 24, but pay attention to the units. The units that we're looking at here is centimeters. So my altitude, to answer the question, is 24 centimeters. Okay, and that'll be the end of the notes. Not sure how much time you guys have left in class right now, but please go ahead and try doing some of the problems from the homework. If you found this video confusing or we're struggling to understand something, just make sure that you're reaching out to your teacher to schedule a time to come in for tutorials.